Okay, so we're moving on to chapter 11, which uses a lot of the ideas from chapter 10. So we're talking about probability and the basic concepts, definition of probability. So I'll mention those as we go through the problems. I won't mention them explicitly at first. Okay, so we're going to do problem number 1. Problems 1 through 4 are basically the same kind of type of question. And actually, I'm going to change this to problems 1 through 4 because we might as well look at all of them. So 1 through 4. So problem number 1, if you go to page 585, you'll see there's a circle with 3 equally proportioned areas of different colors and a pointer. So you spin the pointer. It's like Wheel of Fortune, and it's going to just randomly end up in one of those 3 locations. And it asks, give the probability that the spinner shown would land on red, yellow, or blue. So we'll use A for red. So the probability of something happening is the number of occurrences of that thing happening divided by the total number of occurrences, as long as the final outcome is completely random. So in this case, because they're all 3 equal probable, the total area of the circle is 1. We'll just say it's 1 unit, and so each one is going to be a third. Or you can think of it that we have 3 equal parts. We have 3 choices of equal value. So if we add up the equal values, we would get 3 total, and each one is worth 1. So the probability of red, so we'll put P of red, is the number, the area of the red area divided by the total area. So we're going to use the concept that each one of these is worth 1 unit, and so they total add up to 3. So the denominator, the possible choices are 3, and red is one of those choices, and it has a value of 1, so the probability is 1 over 3, or 1/3. Likewise, the same is true for the other 2 colors, yellow and blue. So the probability that it's going to be blue, again, the blue part, which is over here, is worth 1 unit out of 3 total units, so we get 1/3. And likewise, the probability of getting yellow, I guess I didn't do that in order, is also 1/3. And if you add up all the probabilities, you get 1. That's because we're going to get 1. We're going to get the probability of getting at least one of these colors is going to be 1, because there's no space that doesn't have a color. Okay, so that's number 1. Now 2, what we have on number 2 is we have 2 yellows, we have 1 red, and we have 1 blue. And again, those are broken up into equal size proportions. So the total number of areas that we have 4 areas, 2 being yellow, 1 being red, 1 being blue. So the probability of it being red is going to be the number of red areas divided by the total number of areas, which in this case is 4 instead of 3. And I'll do it in the right order this time. Yellow, there's 2 yellows out of 4 possible, and you simplify that down to a half. So you want to always simplify the fractions. And the probability of it being blue, again, there's 1 blue wedge out of 4 equally sized wedges, so the probability is 1/4. Okay, the third case, we have 3 red, 2 yellow, and 1 blue, for a total of 6 little pies. And they're all equal size, which is important. Otherwise, we'd have to do some additional calculations. So the probability of it being red is the number of red pie slices divided by the total number. We can simplify that down to a half in its simplest form. So the probability of getting red is 1/2. Probability of getting yellow is going to be 2/6 because there are 2 yellows out of 6. So that simplifies down to 1/3. And the final one, the probability of being blue, is 1/6, and that's in its simplest form. If you add 1/2 plus 1/3, 1/6, you'll end up getting 1, again, because we're going to get one of those results. And then the final one, 4, there are 3 red, 3 yellow, and 0 blue. So again, a total of 6. So the probability of getting red is 3 divided by the total number, which is 6, which can be simplified down to a half. The probability of getting yellow is also 3 out of 6, which can be simplified down to a half. And then the probability of getting blue is 0/6, or 0, because blue is not a choice. Okay, so that's kind of how you do it on the graphical standpoint. Now we're going to go straight to 5. So it's the same kind of deal here, except that they're asking some additional questions relating to terminology. We have red, green, purple. And it says, suppose the spinner shown here is spun once to determine a single-digit number. Okay, so it's not colors, it's numbers. And we are interested in the event E that the resulting number is odd. Give each of the following. So what we see is we have, of those 3 equally sized slices, we have 2 which are odd, and we have 1 which is even, for a total of 3 possibilities. The other possibility, so we have 2 odd, even, which is 2, 1, 3, which are odd. So we're going to take ratios of these things to answer the questions. So it says, what is the sample space? Well, the sample space is what is on the dial, and it's a set. So we use these curly brackets, and so the sample space is 1, 2, and 3. That's just the information. Over here was yellow, blue, and red. Okay. Now, the question is about getting an odd result. So odd is favorable. It's favorable is what we're trying to answer a question about. It doesn't mean anything relative to whether we would consider it to be favorable or unfavorable, but relative to our question about probability, it's favorable because they're asking us to find stuff associated with the event that the resultant number is odd. So if it's not favorable, then it's unfavorable. It's one or the other. So the question is, what is the total number of favorable outcomes? Well, we have 2 odd numbers. So 2 favorable outcomes. And then it says how many unfavorable. We have 1 unfavorable. This is 2 odds. So we have 1 unfavorable. And the unfavorable one is the 1 even occurrence. Total possible number of outcomes. Well, these are our total possible number of outcomes. So we have 3 possible outcomes. This all comes down to the fact that probability is the number of favorable outcomes divided by the number of of total outcomes. The total number of outcomes is the sum of the favorable and the unfavorable. So 2 plus 1 is 3. So the probability of an odd number, so let's say the probability of an odd number. Well, since we're talking about odd being favorable, the number of favorable outcomes is 2. The total number of outcomes is 3. and therefore the probability of getting an odd is 2 divided by 3. And then it says odds in favor of getting an odd number. So the odds is different than the probability. And it's just a simple conversion. So it says the rule, if you go to page 584, says the probability of some event, which in this case is being odd, is if that's A over B, then the odds are A to B minus A. So if you have the probability in the numbers, it's a simple matter. So in this case, the odds are, since the probability is 2/3, the odds are A, which is 2, to total number of outcomes minus the number of favorable outcomes. And we don't write it as that. This is the way that we would write it. The odds are 2 to 1 in favor of getting an odd number. So that's kind of how you would write the thing out. The odds are 1 to 2 in favor of getting an even number. You can say that as well. Okay, number 9. So we have a urn, which is just a jar. Ann Kelly randomly chooses a single ball from the urn shown here. Find the odds against each event. So we have red, yellow, and blue. So in this case, the odds were 2 to 1 for, or 1 to 2 against. So we can find the odds for, and then we can just do the opposite. So let's do it on probability. So we're going to look at the probability first. So probability of getting a red. So what we have to do is count the number of occurrences of each one of these things and then add them up to get the total number. So if we do that, if we count the number of red balls, we get 4. If you go look at the diagram, you can count the red ones. We have blue. There are two of those. And then the yellow, there's 1, 2, 3, 4, 5. So 5 yellow. And let me just move this thing down so I can put in total. Put that over here. So total is, let's just write them equal signs here. So you get 4 plus 2 is 6, 6 plus 5 is 11, so the total of 11. So the probability of getting a red is the number of reds divided by the total number. The odds are going to be 4, and this is odds 4. So let's say odds 4 is 4 to 7. 11 minus 4 is 7. So the odds against is going to be 7 to 4. Okay, so let's do the next one. So the next one we're looking at is probability. I guess that's right. Probability of getting a, what's the next one? Yellow. So the probability of getting a yellow is, well, there are 5 yellows, 11 balls. So the odds are the odds for getting yellow is going to be 5 to 6, because you have 5 is the numerator. 11 minus 5 is 6. So odds against is 6 to 5. And then finally, the probability of getting blue so the probability of getting blue is the number of blues divided by the total number. The odds are 2 to 9. 11 minus 2 is 9. Odds 4. So the odds against is 9 to 2. So to me that makes the most sense. Do the probability of something happening, then change it to odds. That's, you use the conversion. And then to do odds for, to do odds against, you just flip the 2. Okay, what's next? 13. So it says the sample space for the rolling of 2 fair dice appears in Table 2 of Section 10.1. Reproduce that table, but replace each of the 36 equally likely ordered pairs with its corresponding sum for the 2 dice. Then find the probability of rolling each sum. Okay, so what you have is a table, and it's going to be 7 by 7. And if you remember how we did this, this was the possibilities for one color of die. It's a 6-sided die, and this is the numbers that you get for the other die. And then what you do is you roll them, and you get 2 numbers, and then you add them together. So 1 plus 1, this is going to be the sum of the 2. So just take the row and the column, add them together. And what you'll end up with is this thing filled out as such, which are the sum of the row and the column designations. And you can see it's pretty simple to put together. We get 36 different choices. I just have to make sure that I don't mess up because I'm talking at the same time I'm doing it. So you have to stay focused. Or just stop talking. And then what we're going to do is we're going to count the number of different possibilities. So the number 2 is seen 1 time. The number 3 is seen twice, and you can see there's a pattern here. Number 4 is seen 3 times. Number 5 is seen 1, 2, 3, 4 times. The number 6 is seen 5 times. The number 7 is seen 6 times, and then it becomes symmetric the other direction. So there are 8 5s, there are 4 9s, there are 3 10s, there are 2 11s, and there is 1 12. And if you add all the second numbers up, you get 36. So total is 36 because there are 36 squares. So as far as finding the probability of all these different choices, it's very simple. The probability of getting a 2 are the number of occurrences of 2 in my table divided by the total number of occurrences. And then you can just go ahead and do all of them that way. The key thing is you do simplify them if you can. In this case you can't simplify it any further, but here you can because they're both even. So you get 1/18 instead of 236. Probably getting a 4. There are 3 out of the 36 that you can get. So that reduces down to 1/12. probability of getting 5 is 5. So you don't use this number. How many 5s do I have? 1, 2, 3, 4. This is actually 4. 4 over 36, which is 1/9. The probability of getting 6, there are 5 of those, so you get 5 over 36, which is as far as you can go. And then probability of getting a 7 is 6 over 36, which is 1/6. And then I'm going to go back up this way because you'll see the symmetry. Just like we saw symmetry in these numbers, the symmetry and probability is exactly the same. So G is the probability of getting an 8, which is 7, not 7, 5. So you got to start going down. So look over here, 8. There are 5 of those. So you get 5 over 36. 8 GH. H is probability of getting 9. There are 4 out of 36 choices, which is 1/9. Then we go to HI. Probability of getting a 10. There are 3 of those. 3 over 36 is 1/12. IJ, probability of getting 11 is 2 over 36, which is 1 over 18. HIJK, so K is the probability of getting 12, and there's 1 case of that out of 36. So you see the probabilities mirror the number of choices. So in this case, we used the table method to come up with the number of different arrangements. We didn't use the fundamental counting principle, but we will use that at some point. We're going to do one more here, and then we'll do another recording. So 17 is a different kind of die. It says it's a 6-sided die has been altered so that the side that had been a single dot is now a blank face. Another die has a blank face instead of a face with 4 dots. What is the probability that the sum of 7 is rolled when the 2 die are thrown? So you basically have to make up another table, just like we did for the original die. We just put in our modified die. So let's do this one as the first one. So it says a single dot is now a blank face. So this is going to be 0, 2, 3, 4, 5, 6. And the other die has a blank face where there are 4 dots. Excuse me. So we go 1, 2, 3, blank, 5, 6. And now we're going to add. So we get 1. So the ones that are going to be different are this whole column is going to be different. This whole row is going to be different. Well, actually, it's only going to be this one here. So it's really only this column and this row are going to be different than what we had before. So these are going to be like we had before. Then this is going to be 2. 0 plus 2 is 2. 2 plus 2 is 4. And then we just count 5, 6, 7, 8. 3 plus 0 is 3. 3 plus 2 is 5. 6, 7, 8, 9. 0 plus 0 is 0. 0 plus 2 is 2. So this is just the same. It's 0 plus every one of these numbers, which is just those numbers. And then we have 0 plus 5 is 5. 0 plus 6 is 6. And then these are filled out as we had in the previous example. Okay, so there's our sample space. This would be the sample space. So it includes the fact we have more than one occurrence. So then it asks, what is the probability that the sum of 7 is rolled when the 2 die are thrown? So the total, the denominator is still 36 because they're 6-sided die. We have to count the number of 7's occurrences. So in the previous problem we had 6 times 7 appeared. What I'm going to do is I'm going to just go through and circle them. So I lose one here and I lose one there. So I only have 4. So therefore the probability of rolling a 7 is 4 divided by 36, which is 1 ninth. So before it was 1/6, now it's 1 ninth, because we ended up with these 2 less occurrences where they did occur before. Okay, so that's this group, and we'll do one more recording for the second group.